Hello everyone, welcome to Skill Dev. Trey here, and in this lesson, we are going to implement a throttle. Implementing a throttle is a very common interview question, so it's essential to understand when going into your JavaScript interviews. Throttles are popular for two reasons. One, they're very practical. We use throttles in real applications very often, and it's something that I turn to very frequently. And in addition to that, to implement a throttle, it's very much founded in the core fundamentals of JavaScript. This is why it's very often used as an interview question. Throttling is a cousin to debounce, another optimization technique, and we cover both in this course because both are very common interview questions. Throttling is a little more complex than debounce, so you should start with the debounce before moving on to this question. It provides a good foundation, and it will also make it easier to understand how a throttle works. So let's dive into our prompt and understand what we're trying to build. The prompt states, write a function throttle that takes a callback function and a delay time and limits the callback from executing to once for each window of delay milliseconds. So the wait time here is going to be 5 seconds or 500 milliseconds. We call throttle, and the callback is simply going to be a console log, and we pass in the wait time. Throttle returns a function, so we'll execute this throttled event listener. Below, we start at time 0, and then we call it 5 times. Even though we call it 5 times, we want to create these evenly spaced windows where it's executed at 0, 5, and 10. If you have multiple events that come within the same window, you only use the most recent event. So that may have felt like a lot, so let's actually visualize what's happening. We're going to have a scroll listener, and on the left, it's going to register a callback each time it sees a scroll. On the right, we're going to have another scroll listener, but it's going to be throttled. This means it's only going to execute the callback over its window. So left, unthrottled, and it will see every event. Right is throttled, and will only see an event over a given window. So notice how with the normal events, we get a lot of events. It executes a callback for every recognition of the scroll. However, in the same window, we get very few callbacks executed when throttled. This is why it's utilized for performance optimization. You strictly limit the amount of events you want to handle, so your client in your browser is doing much less work, and if it's calling an API, it's also sending less requests to your server, which also provides a performance improvement there as well. So let's also quickly discuss how a throttle relates to a debounce. The main difference is the throttle executes over a given window. So as long as you have events that keep coming in, it's going to execute them over these evenly spaced timelines. With the debounce, you wait until the events have completely ended, and then once the debounce timer runs out, then you execute the callback. So with throttle, repetitive, evenly spaced events over certain windows. A debounce, you wait until the end of the timer and execute once. So we saw the throttle takes a callback and a wait time. This means the function will have a callback as the first parameter, and then a delay in milliseconds as the second parameter. So what's happening is every time we execute throttled event listener, it's going to remember what this callback is and what the wait time is. And also, since we can execute throttled event listener, that means throttle must return a function. So what concept allows us to remember the value of variables inside of a function and also returns a function itself? This means we're using a closure. So we take the callback and delay, and then we create a new function inside of throttle. It's going to have access to the callback and delay for every throttled event listener it shares between them, and there's only one value that they all see. We return a function, so this is how we form the closure. returning a function is a very key detail of how you build closures. Then, inside this body, we'll execute the throttle so we can create those evenly spaced events. So in this example, we have a throttled function, and we want it to execute every 500 milliseconds or every half second. We attach the throttled event to a scroll listener, so as long as you continue to scroll every half second, it will execute this callback. So we're creating these windows, so we want it to continue to run every half second. And there are two ways to do this. We can either use a set interval that just continues to run until we stop it, or we can use a set timeout and recursion, so it just continues to call the set timeout as long as we have events that continue to execute. Both will work. With a set interval, it just continues to run forever. So for simplicity, we don't want to worry about memory leaks, so we'll manage that ourselves with a set timeout. When we call it recursively, each time we see an event, we'll just call it again. But then when the events stop, our recursive calls stop, and then we no longer need to worry about it continuing to run. With a throttle, we only care about the most recent event, so let's walk through what happens when we have multiple events that come in. We have an event, E0, at time 0, so this is going to be executed immediately. Then, after executing this event, we start the throttle. We have event 1 that comes in, so we can use it as our throttled event at the execution time. However, we have another event that comes in, so we forget this first event, remember the second event, and then this is the one we want to use when the timer runs out. We get a third event. These are all happening before time equals 5, so they're all part of the same throttle window. We forget 2 since we have a newer one at a later time, and we continue on. Then we have another event, so we forget the one before that, and we store event 4. We get event 5, and then we get event 6, all before this 5-second mark. Finally, that was the last event within that window, so we execute that event, our throttled event, at time equals 5, when the throttle timer expires. Then we restart the throttle. However, there's no events between this 5-second window, so it expires without executing anything and does not start a new throttle. But then we have a 7th event that comes in after this expiration. So it's like we're starting over again. So this event is executed immediately. Since it feels like a new event since the throttle timer ended, it's basically like we're starting at a new time equals 0. So when you have events that come in within the same window, you only remember the most recent one and then execute that at the end of the timer. If you have no events within a window, the timer simply expires without executing a new event and you don't restart the timer. Then if a new event comes in, it's simply the start of its own timer and it all begins again. And now we're ready to implement our throttle function. We know we're going to be using a set timeout for this, so we'll have a throttle timeout that indicates if the throttle or set timeout is still running. We also know that when we have events that come in, we want to store the most recent so we can execute it when the throttle timer ends. We declare both of these variables in the outer scope of the function. We're returning throttled event handler so we can form a closure over these variables, the callback, delay, and the ones we just declared. So now these shared values will be shared with all of the throttled event handler executions, which means these are stored inside the context of this function. So every time we execute it, they all point to the same one because of closures. Now we need to implement the throttled event handler. First, we just take the most recent event that comes in and save it in stored event. This will override any previously stored events, so we're always working with the most recent. We know we want to execute the event if we don't have a throttle timeout running. So if there's not a timeout, we should handle the event. So if we should handle the event, we execute the callback with the stored event. Since this stored event has been used, we now set it to null. Since we've executed a callback, we've used the event, we now need to start the throttle timer. We're going to do this with the set timeout. When the set timeout completes, it's going to execute the callback function, so now we need to add the logic after the throttle timeout ends. The first is to simply null out the throttle timeout because the timer has ended. Now the function is back in its original state. We also need to check if we have a stored event, and if we do, we need to restart the entire process. So if stored event, we call throttled event handler with the stored event. So this recursion is how we continue to get these repeated executions over an evenly spaced window. So if a new event comes in from the previous window, we start the entire process over. So we pass stored event, it becomes this event, we restore it to stored event, we don't have a throttle timeout, so should handle event is true, because we nulled out throttle timeout here. Then we just execute the callback with the stored event, which we passed in down here. So this recursion and restarting the entire process is how the throttle works when you have a set timeout. It just continues to repeat as long as you have events coming in. Because we formed a closure around stored event and throttle timeout, the same variable is used in every single throttled event handler that's executed. If we declare the variables inside here, it would create a brand new one every time you executed the function. So we use the power of closures in declaring it outside of this function's scope, so it's shared between all executions. And that is how you implement a throttle function. Thanks everyone, and I'll see you in the next lesson.